Today we're going to discover how different fractions can represent the same part of the whole. Okay, and what do we call those fractions? Equivalent fractions, right, very good. Students have to recognize what an equivalent fraction is and how to make an equivalent fraction. We started out with the fraction strips, and they saw that although the fraction numbers were different, the part that they represented were the same. And then we showed some examples of equivalent fractions, and I tried to get them to see a pattern in those numbers. If I said, well, you can have half of a cookie, you can have 3/6 of a cookie, and you can have 2/4 of a cookie, are you going to be mad?
No.
Why not?
Even though they're cut into smaller pieces, it's still half of a cookie.
It's still half of a cookie. Excellent answer. Good job. Okay, so how can we make equivalent fractions without using models? Then we pulled the manipulative out, and we tried to find a way in which they could make equivalent fractions by just using numbers without the manipulative. So initially, they understood the concept with the manipulative, and then we could take those away and do the math concept. When we use the individual whiteboards, I do circulate among the rows, and I can see what their answers are, and I can see, I make a mental note, and hopefully I remember my mental note. I make a mental note of who I need to go back with and explain, maybe in a small group setting or a one-on-one setting. Mark, can we show yours? Okay, Mark divided 4/6 by 2, and he got 2/3. And then he took 4/6 again and he multiplied by 2, and he got 8/12. Now both of those are equivalent fractions. Okay, very good. You got it, Gloria. The center that I was having, that I was doing with the kids, were the fraction pieces, and they were actually making fraction pieces from one whole into halves and thirds and sixths and fifths and so on. And then I gave them a ruler, and I asked questions to try to get them to see that, again, with the manipulative, to get them to see that fractions are equivalent, although the pieces are smaller. And then I kind of tried to pull that when the denominator is a larger number, what do we notice with the actual pieces? And they got it. The larger the denominator, the smaller the pieces of the whole. And then we tried to talk about the equivalent fractions of a half and a third, and the test that they could do. They could just pick up a piece of the third, put it over 3/9 or whatever, and it would be the exact same. Yes, it does. So those are equivalent fractions. I try to give them as many different experiences that they can have with a skill. So at this center, they were doing it with a little bit of a flair, a little bit of a competition amongst each other, but they were still practicing the skill. If you put a 4 here, 4/10 is your fraction. You put a little square, red for one team, blue for another team, and you just put the square on here. Now, there is no 4/10, but can I simplify 4/10 to make it a fraction that's on here?
You can divide it by 2.
Divide 4 by 2, and you would get? 2/5. Okay, is 2/5 on here? Okay, so you can put your little square on 2/5. And the team or person that puts 5 game spaces, or that covers 5 spaces, is the winner. The directions are simple, and they get to practice, they get to work in groups, and there was also a whiteboard available, so in case they did need to manipulate those numbers and they needed to write them down, they could do that. And it's always more fun for them to work in a group, and if there's any sense of competition at all, especially in my class, then they're even more motivated to get it right. And sometimes students talking to each other can communicate things in a way that they can understand a little bit better than maybe the formal terminology that I'm using in class. And the Seat Work Center is just a worksheet that I pass out and give them so that they can practice the skill that we were doing on the active board. And then I also use the active expressions at the end of the lesson to see if my lesson was successful. Did a majority of my students understand the lesson? It's an understanding that they have to have in their head as adults. And the example that I used at the end of the lesson with the pizza, would they rather have 3/6 of, or I think it was 3/6 and 5/10 of the pizza? The student that said he would rather have 3/6, he had an understanding of what 3/6 was. He understood that he didn't want skinny little pieces of pizza. He was getting the same amount of pizza, but he wanted the bigger pieces, so he understood the concept. And the young lady that answered that it didn't matter because it represented the same amount of pizza, she was correct as well. And when they wrote that in their math journals, they were actually putting words to the concept. So we do use our math journals as kind of like a recorded scratch paper, but also an opportunity for them to respond in words. When I think of fractions, and especially in my class, we always use food as examples. Ask your child, okay, if I give you this much, how much did I give you of this Hershey bar by cracking off a piece? Or about how much did I give you if it wasn't a perfect crack? Because they can start to get the concept of estimating how much you gave them or which piece is bigger than another. Pizza, cake, pie, all of that can be used to work with fractions.
It's cool. It's all around us. Fraction can just be all around us.
We're done. We're done. And on that note, we did it. Good job, guys.
We can do